Hello, myself Sarthaksha, and I will take your lab sheet number 10, 11, 12, and 13. So let's get started with lab sheet number 10. Lab sheet number 10 talks about pointers, pointer arithmetic, and call by reference. So what are pointers? Pointers are basically variables that store addresses of another variable. Let's say how to declare a pointer. We use the similar syntax as declaring variables. We just use star before the variable name. Let's say I declared two variables like this. Now P and P2 both are pointers and we can access them like this. So let's say I have another variable of integer type. To point to get the address of integer type variable, I will need to use integer type pointer. So and also to get address of another any variable, we use n%. So now my P is storing the address of A. Let's just check it by printing it. To print a pointer value, that is the address, we use %p, and now I am saying that this address is of A. So but how do we know? This is in some garbage value and this is a address of A. So what we can do is I can use this pointer to access the value of A. To do that we use star p. So whatever, let's say I do star p equal to 10. Now my pointer will get dereferenced to that memory location where it was pointing to. So I will again print the same thing if, and this time I will do star p because I want to check what pointer is pointing to. Yeah. So originally my pointer was pointing to this address. Now pointer is again pointing to the same address, but my value of piece has changed. And we can also use A to check that A's values are also changing. Yeah. Now let's see about pointer arithmetic. Let's say I have another variable b equal to 8. I again assign p as address of A. Now I do p plus plus. So let's see. As we know, A and B are stored side by side in my stack memory. So what happens is when I do p plus plus, my pointer will point to the next memory location. And next memory location should not be like suppose my address was 1248. So my next memory location will not be 1249. It will be 1252. Why? Because my integer type variable takes 4 memory space. So it will automatically increment my pointer with 4. Like it depends on what type of pointer is, but as my pointer is of integer type, it knows that the variable is also of integer type, so it will increment it by 4. Mm, yeah. So as you can see, after incrementing my pointer, now my pointer's value is changing to 8, as we expected, because my pointer will point to the next memory location. So that's all about the basics. Now we will start with the questions. So question number 1, we need to write a function circle data which takes the radius of a circle as input parameter and computes the area and perimeter of the circle. The area and perimeter must be available to the function that calls circle data. So whatever we change in the function, it should be available outside of the function, wherever we call that function. So we know whenever I pass a variable in a function, it creates a duplicate copy of that variable. So whatever I change in my original, like in the function body, it will not affect the original variables. So to overcome that, we use call by reference. So what exactly call by reference means is, let's say I have to create a circle data function, and I do need to pass radius. Now I know that from the circle data function I cannot return two things simultaneously. So I will need to pass my area and parameter. Now the main problem was, as area and perimeter will get duplicated, whatever I change in inside the function body, it will not affect what is present in circle main.c, right? So what I will do is I will pass pointers, and this is called call by reference. So let's just see what will happen while doing that. I wrote that function first in like circle.h to just uh, so that when I include circle.h in main file, it will know that some circle data function exists. Now, yeah. So uh, let's first define pi as 3.14. So wherever I write pi in in my code, it will automatically translate to 3.14. Also, yeah, one more thing. All these variables needs to be in float. Yeah. So area will be what, pi r square. Now, as we know, area is a pointer type. So to change the value of that thing, we use star area. And same way, this. Okay. So let's just call this function here and let's see. Suppose my variable radius is 1. I have two variables, area and parameter. I will call this function. Now, as I need to supposed to like I'm supposed to pass the address of this. I will use 9%, and through this, my these like addresses will get duplicated. So my like there will be two variables that are storing the same address, but eventually the address is pointing to same memory, right? So it will not affect, and whatever I change there, it will also get changed in my main function. So let's just check it. As there are three files, I will run them through a script file. Yeah. So let's just check that. Oh, my this file needs to be in lab 10 folder. So, oh, these all are floats. I'll just change that. And in the print also, I will use percentage %f. Yeah. So my area is this and parameter is this. In question number 2, we need to run these pieces of codes and analyze their output. So firstly, before trying I need to show what void star pointers are. So as I told you, to point to an integer type variable, we use integer type pointer. So, but let's say I do not know the type of my variable. For that also, I can use a general pointer that can point to any type of variable. Let's say I have a two variable int a equal to 10 and sorry, character c equal to a, and I declare a pointer p as a void star type. So firstly, I will point it to an integer type, and let's just print them. Now that here you will see the problem. Uh, as my pointer is a void type, I cannot directly dereference it. Firstly, I need to typecast into a particular pointer. So now I will typecast it into a particular pointer. So this will typecast into an integer type pointer, and then I will dereference it. So that will give me a value. And same way, I can also point the same pointer to a character type. And this time I will use percentage %c and character star. So let's just check it. Yeah. So my Varsha pointer can point to any type of pointer, any type of variable. So what size does it take? Generally, it takes the same size as an integer type pointer. Sorry, character type pointer. Uh, yeah. So size of void star pointer is of 8. So in part B, firstly we will see relationship between array and pointers. So whenever you declare an array in C, what compiler does is it creates a pointer that's name is array. So these both are essentially the same thing. Okay. So what the whole line means is they are creating 5 consecutive memory location and assigning 1, 2, 3, 4, 5 there, and my array will point to first memory location. Okay, so star array should give me 1, but then how array 1 and array how we access these elements, how we deal with these elements? So compiler changes them into some this. So my as we know, pointer arithmetic, so array will point to the next memory location. So it was pointing to 1 before, now it will point to 2. So that's why zero indexing is used in array, because initially the array is pointing to the first location. That's why we do not index it with 1. Now to check that, let's just print that. Firstly we will print star array, and then we will print star array. uh, yeah, so these brackets are important because firstly I need to increment my pointer, then dereference it. That should be clear in your mind. And yeah, so array was 1, array plus 1 is 2, and array plus 2 is 3. So another thing, suppose I can also declare a pointer of array. Okay, so what it means is I am declaring array of pointers. So this array will contains of lot of pointers. Okay, and another thing, strings are also character arrays. So to store that also we use this type of syntax. Okay, so my str will point to a, and if I do str plus plus, it will point to n. So I hope that's all clear. Now just let's see this one. It's a little bit tricky, so try to understand it clearly. So in main function, character star array is declared. So what it means is I am declaring an array of pointers. So there are a lot of pointers in my array. Each pointer is pointing to what? Each pointer is pointing to a string. So my first pointer will point to string and the exact it will point to the character a, right? So my star array is a pointer, right? Because the array was already pointed to array of pointers. So my star array is the first value of array, that is another pointer. And if I do dereference it again, so that first pointer will dereference to a. Okay, so the star array will go to a. So I hope that's clear. That's why in function I use this syntax like cat star star to pass this array. And yeah, so let's see what happening in function is. So I am declaring a pointer. Okay, so pointer 1 is pointing to this. So let's decode this. Firstly, I am incrementing my array pointer to size of int. Size of int is what? 4. So the array 4 location. Array 4 location is what? This is 0, 1, 2, 3, and 4. Okay, so my pointer will point to egg. Okay, now I am doing -2 there. So what that means is I will again decrease it by 2 because I know now array minus like array x means star array plus x, right? So this -2 will mean is I am doing whatever the pointer was pointing to -2. So pointer was pointing to egg, so now it will point to cat. Okay, so it will return me the value of that location, right? And that value was also pointer to the cat string. So that's why I'm storing that value in a pointer variable. Now I'm printing that string. To print a string, we use %s, and it will directly print the whole string, that is cat. So let's see if we predict it correctly. Yeah. So I hope double pointers are clear. You can watch once again if it's a little bit unclear. So in question number 3, we need to predict the output of following program without running. So the program is this. Firstly, I want to just remind you. Suppose I initialize a variable this and I print a plus plus. So the print function will first take the value of a, then print it, then increment it. Okay, so output will be 10. And similarly in plus plus a, my value will get firstly value will increase, then it will get printed. Okay, so that's the difference between postfix and prefix plus. So we are given an array, and as we know array is also a pointer. So I am assigning another pointer to the value array. Okay. So this pointer will also point to what? First value of array, that is 22. So if I printf this, as I can see, I am doing star pointer plus plus. So what I told, firstly, pointer plus plus will happen, but firstly print will not work it before printing it. Okay. So before printing, printf will do star pointer, that is 22. Then my pointer will get shifted to 54. Okay. So if I do again printf star pointer, after this it will point to 54. So I hope that's clear. Now in this I am also again my pointer is now pointing to 22 after this line. So here star pointer plus plus. For this we should know what the precedence order of the operators are. So precedence order of like plus plus and minus minus, minus minus are greater than star. Okay. So what this essentially means is this is same as that one, because plus plus is higher, have higher precedence, so it will get an effect first. So there the bracket can be placed. So this will also print what 22, because firstly my pointer will get dereference, then it will get increase. Okay. Now was this the same thing? Yeah, star pointer plus plus, star pointer plus plus. This line was not there, I added it. Yeah, this is the line. So yeah, now as plus plus will like this time also plus plus has a higher precedence and it is only thing close to pointer. So as this is prefix, the pointer will firstly get increased, that is it will point to 54, then it will get dereference. Okay. In this case, as also one thing to know, the precedence order of star and other arithmetic operators are star greater than uh, plus minus multiply divide. Okay, everything. So firstly star pointer will be calculated, that is 22, then it will get incremented by 5, that is 27, right? So it will print 27, and each time after printing we are again assigning pointer to the array, that is first value of the array. Here firstly my pointer will get dereference, and as minus minus is before, so the output should be 21. Okay, so let's just check it if it's working. Yeah, 22, 22, 54, 27, 21. 22, 22, 54, 27, 21. So in question number 4, you need to write a program to reverse an array. Okay, so you are already given a zip file. It will contain 4 files and 2 of them are already implemented. We need to implement 2 files where we need to write function, implement these functions. So in one file, the function will take array as an input parameter of this type, and another file it will take as this. So as we already saw, int array this and int star array are essentially the same thing, right? So what when we write this, the compiler will automatically decode it to this. That's what I done here. You can read it. So we will just like complete the code. So the algorithm I'm thinking about it. Firstly, like I'm implementing in pass by reference, right? So let's say I have a array 1 2 3 4 5. So I need to make that 5 4 3 2 1, right? So I can see that essentially I am swapping first and last elements, right? Then second and second last, then third and third last, and then no more, because yes. So what I'm saying is, if I traverse till half of the array, right? Okay, and you can also like check the edge cases, like when size is odd, uh, they should work. I'm telling you, but you can just explore it yourself. So what I want to do is, I want to for exchanging, I always like firstly assign some value in a temp variable. So let's say my array I, initially like it was array 0, so my temp will store 1 now. Then in array I will store array total like length is size minus 1, right? So to last element is size minus 1 minus I. So my in the first iteration of my loop, 1 will this will become to 5, right? And now array size minus 1 minus I equal to temp. That's why I stored it in temp variable, so that I can change this. Because if I did not and I did the like I just assigned it to array I, my array I was already changed to 5, so it will again change to 5. So this should work for this. Now for pass by pointers, we can see we can apply the same logic. Yeah, so this time the accessing method will change. So I will access them as like this. Array I was essentially the same thing, right? We talked about it already. Now firstly create a temp variable. Now array star array plus I equal to what? We need to again like change the pointer to the last like from last ith element. So from last was this minus ith element. Okay. These exact numberings and edge cases, like you can just explore it yourself and try to understand why that this is there, and then this. So this will work. I can just run all these files together and check if it's working or not. So in my script file, firstly let's check with pointers. Oh, I need to like compile both files actually, because in my main function I am running both functions, right? Print array by pass by reference also and pass by pointers also. So yeah, the script file system, I hope you already know that, because it must be taught in your previous lab. And I will just run that uh, sh script.sh. Okay. Oh, reverse array pass by pointers. Okay. Acha, again this here also. So yeah, arrays before reversing, arrays after reversing using pass by reference, and after reversing again they are the original arrays. So I hope it's clear. In question number 5, we need to transpose a 2D matrix, and again by two ways: transpose by reference and transpose by pointer. Okay. So firstly, let's understand the structure of matrix, right? You're again given a zip file that will contain three files: transpose.c, transpose.h, and transpose main.c. So in transpose main.c, you can see there's a matrix given, right? So again, this is again an array, but this time this is not array of arrays, right? It is essentially array of arrays, but we use only like one pointer to access this. Why? Because uh, let's say mat1 is already a pointer, right? uh, to an array pointer. So star mat1 will point to 1. Okay, the first value of all the matrix. Star star matrix plus 1 will point to this, plus 2 will point to this, plus 3 will point to this. Okay, plus 4 will point to this. Why? Because all these memory locations are located side by side. It's not like some different location. There are four arrays created and we are combining them in form of pointers. They are all contiguous. Okay, so as I told you initially, so what mat1 xy would mean is, mat1 xy means is star. Firstly, I am going to xth row. Okay, so I am traversing x rows. So in each row, I will travel how many locations? 4. So I will do is what? 4 times x. Okay, in each row, I am traversing 4 locations. So when my x is 1, I need to look in this row. So an array plus 4 points to this, the first of second row. So this will lead me to the row I want to like access the element, and plus y. So the element in that row. Okay. So matrix represented in this will translate to this. Okay. So firstly we will deal with pass by reference. Oh, I already did it. So this is reverse by array. Okay. Yeah. Yeah. Transpose dot c. Yeah. So in transpose by reference, firstly, like let's think about the algo. What, how we will do it. So the transpose of it will be what? Like um 1, 4, 5, 6. The column becomes my new row, right? 1, 4, 5, 6. Transpose will make this column as my first row, right? Uh, this column, second 2, 6, 9, 2 as my second row. 2, 6, 9, 2. Then this will what? 3, 7, 3, 5. And this will be 4, 2, sorry, 4, 2, 1, 1, right? So just analyze it. When I am calculating transpose, I am saying I am just swapping like array ij with array ji, right? So array 0, 0 array 0, 1 was what? 2, and array 1, 0 was what? 4, and I am swapping both of them. And for each element, I am doing the same thing. So essentially, I need to do this like, but I do not need to like traverse on the complete list, because firstly, what if I traverse on complete list? Firstly, I will exchange 4 with 2, then I will again exchange 2 with 4. So after 2 swaps, they will be both at same location. So I need to swap only till like some half. So what I can do is, I will only swap till diagonal elements, and each row I will swap till diagonal elements. So for in this row I will only swap 1, because like I do not need to even swap 1, because 1 is at the same location. Array ii is always equal to array ii here. In third row I will swap till here, and in fourth row I will swap till here, so that it gets swapped only once and the transpose is calculated. So what essentially I'm telling is, I will traverse in each row, right? But I will traverse till I, that is ii, array ii, will till only I will traverse. I will not traverse the complete array. So in each row, I need to swap. So for swapping again, firstly create a temp variable that is equal to array ij, array ij equal to array ji, and array. I will just like rename it to array because I used array everywhere. Array ji equal to temp, right? And by same logic in pointer again, firstly like again recall matrix x y translates to star matrix plus number of rows x, so each row will get 4 memory locations plus the location in that array because all rows are stored side by side, like side by side in like in stack 1 by 1. So just I will just leave it there. Now again traverse till diagonal elements. Temp, again temp variable, just the syntax will change, star matrix plus 4 into I plus j, right? Now I will change this to ji, so gi will be what, matrix plus 4 into j plus I, and I will again change this to temp. So I hope this should work, and again I will write the script files. C transpose dot c, transpose main dot c, o xc, okay, let's check that, and I hope it should work. Okay, so matrix before transpose, matrix after transpose, and matrix after again transpose.